So NeuroFedora is, as if you can see my screen, you'll see our documentation page. This is the primary landing page for NeuroFedora. Now, NeuroFedora is a Linux distribution. It's not one tool, right? So the way you have OpenSUSE or Ubuntu or CentOS or Red Hat, Fedora is another one of these. So that's the Fedora landing page for the documentation. And the primary goal of Fedora is to promote free and open source software, right? So it's a free and open source, what I'll refer to as FOSS community. And as FOSS communities go, it's meant to be a combination of a bit of philosophy on FOSS. So that's the Freedom Foundation. It's community-based, so a majority of us are volunteers. A few people do get paid by Red Hat, which is the backing organization for Fedora. But a majority of people that work on Fedora are volunteers, right? So they have their day jobs, they have their families, and they find the free time to work on Fedora. So that's the second foundation. The third foundation is features. Now, Fedora is upstream for Red Hat Enterprise Linux. So if you've used supercomputers somewhere or clusters, you'd probably have used Scientific Linux or CentOS. And these are remixes of Red Hat Enterprise Linux. And RHEL, as it's called, is also free and open source. The difference is that you pay for support, right? So the connection between all of these is that Fedora is the one with the shortest lifetime. So you have a 13-month release cycle. Every 6 months, there's a new release. And then the software that's in Fedora gets tested here, new features get tested here. And when they are nice and mature, they get down to Red Hat Enterprise Linux, right? That's not to say Fedora is unstable. It just has the latest version of software, whereas Red Hat Enterprise Linux will have, they'll have, let's say, longer term releases, right? So that's what features and first stand for. And the way the community is organized is that it delivers a few artifacts. At the moment, there are 3 primary products. So one is a Fedora Workstation Linux distribution. This is just a plain Linux distribution that's based on GNOME. That's what I'm using right now. So if you see my screen, you can see this is just a GNOME installation. It's got the standard workspaces, right? It's got all your apps if you want to use them, Chrome, new Octave, and so on, Firefox, and yeah, right? So it's just a Linux distribution. The workstation is based on GNOME. But because it's a community-based distribution, yeah, Jim, GNOME 40 really is nice. I've just started using it about a week ago. But I think you'll notice they've made it a little Mac-like, where you've now got horizontal workspaces rather than vertical ones. Yeah, so that's an example of Fedora being slightly feature-oriented, right? GNOME 40 is still in beta, but you can already try it out in Fedora, right? So that's the Fedora workstation that I'm using. This is for laptops and computers. They have a Fedora server distribution, which is meant to be headless. So this is for server deployments where you don't have a GUI. So you'll SSH in, or you'll use something called Cockpit to administer your server. And finally, they've started moving on to IoT, Internet of Things. Now, I don't know a lot about IoT, so you'll have to check that out yourself. They work on other things like Core OS, which is container-focused operating system. So the idea of Core OS and Silverblue both is that you have an immutable desktop operating system. It's a new technology that's called RPM OS tree. So your main operating system is an image, and then you work on this operating system using containers. So you layer up as you would with containers, right? So these are 2 new features. But because it's community-based, if there are enough people that want to work on another variant of Fedora, you're free to do so. And that is why you have multiple spins, right? So for example, instead of using GNOME, if you want to use KDE, there's a KDE special interest group that developed the Kde Plasma Desktop. It's the same thing, but instead of GNOME, you'll have KDE, right? And then, well, with open source, there are so many different desktop environments. So KDE is one of them. You can use XFCE, which is lightweight. LXQT is another lightweight one. There's Mate, which is which used to be GNOME 2. There's Cinnamon, which is OpenSUSE's version of GNOME Shell. There's LXDE. Yeah, I mean, it goes on and on, right? So people all over the world, if somebody wants to use something, they get together, they develop a new spin. So spins are organized based on desktop environment. And then you have another version, another set of variants, which are called labs. So labs are for different functions. And as you can see, there are people in the Fedora community that work on astronomy. So you have an astronomy variant. The Conf Neuro variant is what we have developed. This is our first deliverable. And what Conf Neuro is about is you get the same installer image, but it's packed with lots of simulation tools. So for example, you have Neuron, you have Brine, Genesis, you have Nest. We have the whole Python science stack because we would like people to use more Force tools rather than MATLAB. We also include GNU Octave, which is the free and open source alternative to MATLAB. It's not a drop-in, but it works in the same way. Most of your MATLAB code will also work there. We also got Moose. And with this release, the next release for Fedora is in 2 months' time, the 34th release. We're also going to have NeuroML, Pine, and NetPine included here. Now, these are only tools that I'm referring to as featured, but actually, we maintain about 165 packages. Now, not each package is a tool. A lot of these can be libraries. Because I work with computational neuroscience, I tend to take care of software related to computational neuroscience. But for example, Morgan works on neuroimaging. So he helps out with software that might be used in neuroimaging. So that is sort of how NeuroFedora works. The one important distinction between developers of simulators and NeuroFedora is that we are downstream, right? So we don't develop Neuron, right? The Neuron developers develop Neuron. What we do is we make it available on Fedora. So we will build it for you, we will test it for you. And once it's been converted into an RPM, which is the package format for Fedora, then you can install it easily on your system, right? So I can show you a demo. So for example, is the font big enough on my terminal, or should I increase it a little bit? Can everybody read what's going on? Yeah, great.
It's fine, yeah.
Okay, so I have Neuron installed in my system, right? And then I also have the Python bindings for Neuron installed, and which means I can basically, right? And the way this works is that all of these packages, if you use any Linux distribution, you'll know there's a concept of repositories. These repositories are what hold these packages that you can install in your system. And each distribution tends to have a default package manager. So Fedora has DNF, and then you can install whatever packages you want, right? So at the moment, it'll tell me that I already have Neuron installed. Oops, wrong password. It's thinking. Yeah. Now, if you install from the comp neuro image, if you use this image right here, then you don't even have to run the DNF command. All of this stuff is already included, right? And I believe I have downloaded an image, so I can show you how that would look. Right, so that's my ISO that I've downloaded from the website. And I can show you in my virtual machine tool. Let's do this. So all of these images are also live images, which mean you don't necessarily have to install them. You can just use them live, right? So I'm not installing it. I'm just going to boot it live. I haven't actually tested out the ISO, so hopefully it'll work. If you have any questions, you can ask them in the chat. I have a second screen where I can see the chat. Right, so you get two options. You can either install it to a hard drive or you can just try it out. I'm going to try it out for the time being. And then it's a standard GNOME system. This is not GNOME 40, this is GNOME 3.38, so it looks slightly different. But this is a fresh system, and as you can see, right, so I can import all the packages I already have, or I can import Nest, I can import Prime 2, because all of these tools are already available on this image, right? You don't really have to do anything. So the advantage here is that you don't really waste any of your time building these things from source and debugging issues and installing all the dev tools that you need. We do that all for you. Yeah, Shailesh, so you can't do it on this particular image because this is pre-built, but you also have something called a net installer, which means, so the installation wizard will be the same, but there you can pick individual packages that you want, right? It's also quite easy to actually build your own live image. I can, if somebody's interested, you can always speak to me off list and I can show you how that's done, right? And I know traditionally people always assume that Linux is very hard to use, but that's not really the case, okay? It used to be maybe 10 years ago, but now everything you need is here, right? So you've got browsers, you've got mail clients, you have Thunderbird, you can run Chrome and all your proprietary software. We won't provide it because we are, well, not anti-proprietary, but we are pro-force, but you can install all of that. Okay, so I can show you all of that on my machine. Right, so I'm going to turn this VM off because it seems to be killing my laptop. And you would have noticed this tool here is called GNOME Boxes, which is built on libvirt, right? So it's not using VMware or a proprietary virtual machine technology. This is libvirt, which is a free and open source machine technology. And it's quite advanced. So this is the simple interface, but you also have another very, very advanced UI where you can manage quotas and all your NATs and network configurations and so on, right? Because all of this is, a lot of it is, I wouldn't say developed, but invested into by Red Hat. All of this is always available in Fedora, right? So that was the overview. Now, the advantage of the way we do things is that we have only shown you how the live image works. You can actually use all of this software also using containers, right? So yeah, Joe. So I don't think I have them enabled on mine, but the new GNOME has all of your touchpad features enabled. And I think that is the idea of going to the horizontal workspaces, so you can swipe left or right to go to your workspaces. Okay. Yeah. So when I speak about how we develop this, you'll see that everything gets packaged into an RPM. And once it's in an RPM, you can deploy it in different ways. Now, one way of deploying it is using your package manager where you install it. But because it's an RPM, we can also now publish it to the Fedora registry. All right. So for example, here we've set up a comp neuro container. Right. So the comp neuro container mirrors the live image, right? So Nest, Neuron, Brine, Pine, everything that you have in the live image is available to you in a container using the comp neuro container. You'll notice I use Podman here. It's a drop-in replacement for Docker. If you do use Docker, you'll know that you need to run a Docker daemon, which has to run with super user privileges, which, if you really think about it, is a security issue. So Podman is meant to be an alternative to Docker, where you don't have to run a daemon as a super user. Most of the containers can run rootless, and then you can enable your root container if you really must. So all our documentation will use Podman because we prefer Podman. So yeah, so the commands are all here. I'll share the links with you for documentation, but it's a standard way of using a container. You pull your container from your registry, and then if you want to run it interactively, you run it using the IT flag with bash, and then you have your terminal in the container. You can do everything that I just showed you in my terminal. Yeah, we do have Singularity, although Morgan, you might have to explain that later because I haven't used it. And if now the comp neuro images by design include lots of different simulators, but for your own research, let's say you only want to use any one simulator or one package, you don't really have to pull this large image down. You can pull a standard Fedora image, you can run it again, and then you can install whatever simulator you want to use on this particular image, right? So it's the standard way of layering your Docker image with add-ons. Yeah, and then you have IPython. You can run whatever you want over here. For reproducible research, we're trying to move more and more to Docker. So you run your simulations, you run all your scripts, and you place them nicely into a Docker container so that other people can use them. The standard way of doing this is using a container file or a Docker file. Again, because you have a Fedora-based container, you can create your own Docker file. So for example, this one here creates a Docker file that includes Nest. I've just put Nest test here as an example, but this will generally be your simulation code or your post-processing code. And yeah, you can build your container in the standard way. You can share your container. You can publish it onto whatever registry you want, the Docker registry or another one if you have a private one. And then, of course, anybody can pull your Docker container, run it. And you see here that my test script runs. Right, so these are the two primary deliverables. We include lots of software. I take care of the computation neuroscience bit because that's my area of research. We've got Arbor, Orin. I've never used BioNetGen, but we have somebody who uses it. We've got Brine version 2. We've got Brine version 1, but in a different repository because it's Python 2 only. And we've deprecated Python 2 now since it's no longer supported. Yeah, we've got Genesis. We've got a lot of the NeuroML stack. We've got Muse, we've got Moose, we've got Music, we've got NetPine, we've got Neuron, and yeah, and a whole host, right? Pine, SciUnit, a lot of the others. And all of these can be installed using one command, okay? We have some neuroimaging software that Morgan's been helping us out on. I would love to work more on neuroimaging, but I don't know much about it. So we are hoping that we'll gain contributions from people from this particular domain who will help us develop this. We've got lots of data analysis packages. Again, I don't use a lot of them. I use a few. We've got all of TextLive. So if you use Overleaf or you use LaTeX to write your documents, we've got the latest distribution, right, along with some helper tools. Some software we exclude. So Brine 1 is Python 2. So this is in a Cooper now. If you have used this tool called FSL, it's developed by the University of Oxford. It's very, very commonly used in neuroimaging with fMRI and that kind of work. Unfortunately, even though the license is meant to be forced, they prohibit commercial use, right? And most people think that's all right, but if you prohibit commercial use, that makes your license a non-free and open source license, right? So that clause means we can't distribute it. So if you are starting a new project, please do not put that clause in if you really want it to be a forced project. And yeah, and similarly, because NVIDIA doesn't, well, their drivers are proprietary. So you can get them from the sister repository, which is called RPM Fusion. Again, it's one command. Yeah, so you need to install it that way. Similarly for CUDA, right? The added advantage, again, is where applicable, we also build all of these packages with MPI support, right? So for example, we have Nest and Neuron built with MPI support. Yeah, so you just have to go DNF install Neuron MPI CH or OpenMPI, which are the two MPI implementations that we support, and that's ready to go. Okay. So hold on, let's have a look at some of the. So NeuroLib is already on the queue. I will talk about that later when I talk about how we get new software in NeuroFedora. Shailesh, I'll talk about tests. We do both. We run the test suites that the software includes, but there's also a QA system that all packages must go through before they get to users. Kagla, that would be awesome. Maybe you can help me with NeuroLib. Yeah, Morgan. Yeah, I think Morgan is referring to FSL. Yeah, FSL is not a trivial package to build, but if somebody wants to work on that, we can discuss that later. Okay, so that is what NeuroFedora brings to you. Because we have containers, because we include Jupyter, we include all of that. We think it's also quite a good platform if you're teaching computational neuroscience, right? Because your students no longer need to install all of this on their own. All you have to do, tell them is, get this image, you can run it in a virtual machine, or you can install it, and all the software they need is ready to go, right? And in fact, as I said, you can customize the image. So if you have a particular class and you want to include tutorials and source code for your students, we can also develop a live image for you, right? It's really easy. It takes about 10 minutes to come up with, right? And now we are, it's a completely community-driven project, which means nobody is being paid to work on this. We have not applied for any grants yet. We have resources from the larger Fedora project, and I'll talk about those. But all the contributors here work on this in their free time. And but because I am an OCNS member, I try and do a poster every year at OCNS just to keep the community abreast with what we're doing. We don't really have a plan to write a paper yet. If you're aware of NeuroDebian, there was a Frontiers paper on NeuroDebian that talked about how it is. So maybe in the future we'll do so, but we'd like to perhaps get more software in and make it more of a complete system for everybody in neuroscience before you think of a paper. Right, now with that, before I move on to the development aspect and talk about contributions, I'll quickly tell you how to get in touch with us. We hold open meetings every 2 weeks, right? These are open for everybody to join. And all of these meetings happen on public channels. So yeah, because Fedora has been around for a while, we still use IRC, but that doesn't mean that you have to use IRC. You can also use Element. So I can show you that actually. So this is, well, my IRC client. You don't have to use this at all. There are GUI clients that you can use. But this is the IRC channel. You can see it's called #Fedora Neuro on Freenode. Francisco D is my nick. In FOSS communities, everybody has a fancy nickname, right? It's like an alias. And this is what I decided on 10 years ago. Yeah, and I can say something here. And I've said this here because I want to show you that all of these are bridged. So that is IRC. If you want to use IRC, you can. It's very simple, only text. You have no histories generally. You can't share images. You can use emoticons if you want to. No GIFs, none of the WhatsApp things, no status updates, nothing. It's very simple. You talk to each other when you're around. There's another platform now called Element. So this is meant to be IRC. The upgrade to IRC is based on the Matrix platform that Mozilla and some other organizations have been working on. So this is IRC version 2, right? And now this is, well, as you see, it's got a full feature client. It's got reactions and all that, right? And the important thing is that our IRC is linked to our matrix. So you can see my message here. And this is Aniket Mioja. Clearly, he loves cats. And you can see that his message shows up on our IRC side of things. Now, finally, if you don't like any of these and you're a Telegram person, we also have the Telegram channel here. It's at, I think it's at NeuroFedora. I'll just have a look quickly. Yeah, at NeuroFedora. This is also linked, right? So you can see my message and Aniket's message here, right? So pick whatever platform you wish, and you can get in touch. And so when we have meetings here, you'll be able to see all our meetings, all right? So that is the synchronous communication channel. Now, given that you're spread out all over the globe, sometimes it's not possible to speak to each other in person. For that, we also have the mailing list. It's a standard Mailman mailing list. You're looking at the interface is called HyperKitty. Yeah, as I said, FOSS has fun, weird names for all of these things. But you can look at our archives here. This is where all the announcements go. This is where new people introduce themselves. This is where we'll send contribution opportunities. So this is the announcement for our meeting. And then this is also where I will share the logs So I chaired this meeting, but we try to take a round robin method where every contributor chairs a meeting, right? So yeah, so these meetings are an ideal place if you want to get started in your Fedora, right? So that's how you communicate with us. We also have some presence on GitHub, even though we don't use it much, because we have our own free and open source Gitforge that I'll show you later. We primarily use GitHub for the blog, which is here at neuroblog.fedoraproject.org. I'll actually paste this here for you. Right, and again, from the blog, you have links to all our channels in the top bar here. Right, and the blog is similar. It's used for announcements. So if the next meeting, the agenda will come up here, or the announcement for this session, for example, came up here. And this is hosted on GitHub pages, which is why we have some GitHub presence. We also host 2 planets. So a planet is an RSS feed aggregator. So this is Planet Neuroscience, where we aggregate RSS feeds from lots of peer-reviewed journals, well, whichever the ones that still provide RSS feeds. And there's also a Planet Neuroscientists, which is an aggregation of RSS feeds from different blogs. Either they could be related to neuroscience, they could be individuals in neuroscience. So if you have a blog where you talk about neuroscience, or if you develop a tool and have a blog that publishes RSS feeds, please let us know and we'll add you here, right? Again, the point of the aggregator is, you can either view it on the web, or you can download the blog roll and subscribe to all of these feeds in your own RSS feed client, right? Yeah, this is based on a very, very simple tool called Venus, which you just set up. You just provide the URLs for RSS feed, and it spits out this page that you can then put on wherever you want. Okay, yeah, we're on Twitter. If you had come early, you would have seen me tweeting from this account. Again, Twitter is used to spread the word. It's generally announcements, meeting announcements, logs, that kind of thing. Depending on when so Aniket and I manage this account right now. We're trying to get more people in different time zones to manage it. Again, the idea is if you're online and logged in with this account, you see something neuroscience, you see something INCF related or a tool related, you retweet it just to kind of give it a bounce. Okay, that is where we are. Okay, so that is kind of a much longer introduction to NeuroFedora than I would have wished. Are there any questions now? So far, any comments? Otherwise, I'll move on to the more technical aspects of how we do all of this. Okay, nothing there. Okay, so I'm going to start, I'm going to go in a one-way, I'm going to go downstream, right? So I'm going to start from software, and I'm going to show how it gets in your Fedora. So I said we don't use GitHub a lot because we use something called Pagure. Pagure is a free and open source Gitforge. As you see, it's pretty much the same as GitHub. It's got the same features, right? It's got the same README. You have your commits, you have your branches, and you have the issue tracker. So, so this is what the Fedora community uses. This is what's deployed in our infrastructure. And the first thing that happens when we notice some software that we think is useful is we throw it onto the list, right? So we have a rather long list. We have 215 packages, which shows you how much software there is out there for neuroscience. I will focus on Comp Neuro. Right, so these are all our tickets. Again, there's so many tools that I didn't know of, but you read a paper or somebody nudges you and you get to know. And so, for example, NeuroLib is on our queue here, right, which is assigned to me. It requires a few additional packages which need to be included before I can include NeuroLib. For today, I thought I'd do Brian as a case study because that is the first session that we had done. right? And I can show you how it came about. So it went down our queue. At this point, this is 2 years ago. So at this point, you're still looking at Brian 1. My initial comment was, well, Python 2, so we can't do that. And then we started working on version 3. So the idea is that I will take the software from upstream. So Marcel here, for example, is upstream. And right, so this is where the software is developed. This is upstream. This is so upstream and downstream come from thinking of all of this as a flowing river, right? So this is the mouth of your river. This is where all your software originates. And each time the Brian team with Marcel make a new release, it'll show up as a tag over here, right? So the current release is 2.4.2. And what downstream distributions like Fedora do is we'll take these and we'll build them in our own infrastructure to convert them into binary RPMs, right? So we'll take the source code and we'll make a binary RPM out of them. So for example, this is where all the package sources for Fedora are. So if you go to source.fedoraproject.org, you can look at all our sources here. Okay, I'll just share the link. We're currently looking at Brian 2. This gives you an overview. So for Fedora 32, 33, and 34, 32 and 33 are current releases. 34 will be released in 2 months. 35 is called a development release, which in Fedora jargon is called rawhide. And you can see here what versions of Brian we are currently shipping in these different releases. I won't go into the details of how we build these RPMs, but the core here is that you write what is called a spec file, right? It's basically a standardized shell script, okay? So there are some standard tags, for example, the name, version, release, a summary, the license, and all of this, right? You have a standardized tag for build requires. So any software that's required to build another software becomes a build requires. Any software that's required to use your software becomes a runtime requires, right? So it really is a standardized shell script where you are putting in all the metadata required to build this particular software, right? And then you have a prep section where I can add whatever patches I need to put or make other changes if I have to. We try and not to carry local patches. If there's a patch that we carry, we try and send it upstream because we want it to benefit all the ecosystem, not just Fedora. Then you have a build section. This is a macro which literally runs Python setup.py build, right? That's literally what it does, right? That's where I build the documentation using Sphinx. Again, this is the install section. It literally does Python setup.py install, right? It installs everything. This is a check section. This is where we will run whatever tests we can. So if there's a test suite included in the software, we will run the whole test suite. And I'll show you in a minute that we support multiple architectures. And sometimes, even though the test suite might pass on one architecture, it'll fail on another, right? And then after you've run the checks, so you've run your test suite, you list the files that this RPM should contain, right? So Python site arc is basically user lib64 Python 3.9 site packages. And then you have Brian version and -pyth, that's the egg info. And then over here, you'll have Brian 2, right? So I can actually show you this here. Right? So because we have this metadata in the spec file, RPM knows exactly what files are included in your package, right? And all of these are installed in system folders, right? So we follow the file hierarchy system standard, which is the FHS. That's here, right? You can also, if you're using Linux, you can use the man page to see where different things should go, right? So the idea is that it's a system installation, right? It's not a user installation. It doesn't go into your home directory. It's not a conda environment. It's not a virtual environment. It's available to all users on the whole system, right? So I will write the spec file. Now, just because I've written the spec file does not mean that this is ready to go into Fedora. We have quite a rigorous review system. And I will see if I can find the review for Brian too. This one looks new, yeah. So the way things work is if I want to add something to Fedora, I submit a review. And then let's try that. And then somebody else from the community will then review this for me, right? So I'll submit the spec file with some description of the tool. And then there's a checklist of things that another community member will verify for me, right? So some of these are important. Some of these are what we call blockers, which means if that issue persists, then you need to fix it before the package can go in. As you see, Brian is quite well developed, so I didn't have a lot of trouble. Everything was tick, 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 tick for most of it. And then we run additional checks on them. Again, all of these are they're generally meant to be suggestions, right? Okay. My friend has said, okay, fine, your package looks good, it's approved. Once it's approved, it then officially enters my Fedora source repository, right? So that's when this is created for me, and I become the maintainer along with the neurosig, okay? So now I have my spec file, which are the sources to build Brian in Fedora. Next thing I do is I will build Brian, right? So for this, we have a build system. It's called Koji. And what the build system does is it will build your package for all architectures that we support, right? So we support the usual 64-bit, and we support the usual 32-bit systems, right? At the same time, we also support lots of other architectures. So we have support ARM, we have support Arch64. There's even a PowerPC special interest group that helps us build these tools for PowerPC. There's also a S90X, which I've never used in my life, but yeah. Right, so these are the different architectures we support. Now, Brian is Python, but it has a compiled component, right? Which is why all of these compiled components must be built individually for all of these architectures. And this is where sometimes we catch issues with different tools. Let's see, I'm hoping I can show you an example for how we caught one of these issues in Nest. So Nest, I think at the 2.16 release, had, well, Nest uses Travis, as most people do. Unfortunately, Travis, for quite a while, has only provided 64-bit systems for tests, not 32-bit systems. So I was building Nest on Fedora, and we realized that it would not build on 32-bit systems, right? And as a Fedora package maintainer, one's role is not just to build for Fedora, but when something goes wrong, we kind of are the middleman between users and developers. So I went back to the Nest folks and said, well, I'm seeing this error. I'm not able to build this on a 32-bit system. And after some investigation, we found that they had made some low-level changes that prevented Nest from building on a 32-bit system, right? So in this way, we were able to help Nest make sure that they also support the architecture they want to support. Now, one doesn't have to support all these architectures. A lot of tools will only support 64-bit, but then you have to clearly mention it in your documentation, right? And then in Fedora, we can exclude those architectures, right? So at this point, now I have Brian built. You'll also notice Debug Info packages here. These are used to create stack traces if a crash occurs, right? So let's say you're using Brian and it crashes for whatever reason. You can install this package and it'll include all the debug information and all the symbols. And if you use GDB to generate a stack trace, you'll get a full stack trace over there, right? Generally, you don't need to use the debug information. It's something we generate for all architecture built packages. Right, so now we have Brian built and ready, but it still hasn't gone to users because after it's built, it needs to go through the quality assurance process, right, which is the QA process. For that, we come to a different tool called Bodhi, right? Bodhi is a QA system. It's strongly linked to Koji. And so for the latest release, for example, I created this build for 2.4.2. I submit this to Bodhi. And here now users have the opportunity to test out this update and see if it works for them, or just notice something wrong. So now we've gone through 2 contribution opportunities. The first is you can become a package maintainer and build things from source to include them in Fedora. The second is you can just be a user, but you can give feedback to these updates, right? You don't have to do anything special. You use the new update, you see if it works, and then you give a thumbs up over here. For some tools, we even have a test case to help people who are not well versed with Brine. So we include some examples over here and see whether things work. So somebody can run through this test case quickly, and then they can say, yes, this test case worked for me. It does fix this bug. So in this case, it's just a bug that says a new version is available. But if it's a bug fix release, then I will mention the bug here, and then you can add a comment and feedback. If it doesn't work, you can give a thumbs down to say no, do not push this out to users because something is wrong, right? In this case, I mean, as a maintainer, I will always test out the package myself, but there's no way one single person can try all test cases, right, and cover all use cases. So more people testing out always means that you're more likely to catch any regressions, any bugs that might slip through, right? Now, after this is done, you can see the statement here, right? So it stayed in testing for 7 days, didn't get any negative feedback. Then Bodhi tells me you can now push this to stable. It's ready for use by your users. At this point, it enters the repositories where you can then go DNF upgrade, and you'll get the new version of software, right? So this is the core pipeline of how packages enter Fedora and are distributed to users. Any queries here? I need to drink some water, so I'm going to pause for 2 minutes. It's quite standard software development. We follow the same process. The difference is that we're taking software from upstream and building it to give to users. We're not developing software ourselves, right? That does not mean that we won't contribute upstream if there's a bug. And for example, I'm the maintainer for Brine, and if I know how to fix this bug, I will create a patch and I'll send it upstream, right? We'll carry it locally until a new release is made. When the new release is made, we'll drop the patch, right? Yeah. Now, once it's hit Bodhi, again, in order to get this out to the different mirrors for repositories, we don't have to do anything, but if somebody is interested in contributing to the infrastructure side of things, there is right. So there's software that helps to synchronize mirrors all over the world. Lots of universities contribute bandwidth and host Fedora mirrors so that you can get your packages quickly. So if you are at an educational institution and well, an IT listens to this kind of thing, you can set up a mirror, right? I did try it at the university I was at previously. It's not easy to get IT to take up this kind of task. But if your IT does support Linux and that kind of thing, you can always ask them to give us more bandwidth. Yeah, so that is the software side of NeuroFedora. But that does not mean this is where contribution stops, because we are part of a much larger organization, right? We're part of Fedora. So for example, this logo you see here, somebody from the Fedora community made it for us, right? We went to the Fedora community has a design team. So let's see. So I can find a different ticket actually. Right, so this is the Fedora design team. If you want some artwork, you want a brochure, you want a logo, you want stickers, you file a ticket with them. And the super helpful people who know how to do things, because I mean, I know how to open Inkscape and I can draw lines in there, but that's where my knowledge of Inkscape and GIMP stops. But they will work on it for you. So for example, we wanted a brochure to give out a CNS, right? They build that for us. And again, I mean, each team will have their own review process. So again, here, everything will happen in the open. None of this is private, because as a free and open source community, you default to open. And yeah, so this is Mary. She's one of the design team leads. So again, she'll review this for us. She'll say, yeah, this follows the different guidelines for design. This has the right color scheme. Your text is legible. Everything makes sense. So this brochure is now ready for you to use, right? Similarly, the design team also made stickers for us. right? I file a ticket saying, I'm going to CNS and I would love some stickers for us. Can you please help us with that? They ask me for specifications, and hopefully this will load over here. Yeah, so I mean, they give you different designs and you pick the ones that you work for, right? And so that's why we now have stickers for NeuroFedora. If this meeting were happening in person, I would have carried a lot of stickers to give out, because that's what you do at unconferences and tech meetups. So that is another contribution opportunity. This website, again, is on Fedora infrastructure. There's a different special interest group that takes care of these websites. Right, so setting all of this up. Again, so if you're interested in web development, this is another place where you can help out at. Not only do we do websites, we also do translations of these websites. So there's a platform called Weblate. Let's see if I can find it. I think it's just weblate.fedora project. Oops. Okay, I can't find the UI, but yeah, but I mean, if you speak a language other than English, you can help translate this page into other languages. Again, so after CNS, we had somebody who emailed me saying, oh, you know, the French translation is incomplete. And they sent me the whole text for all of this. So I just went to the Weblate platform, put it there, and now we have a French translation for this page, right? That's another contribution opportunity. Documentation is super, super important. Everybody is well aware of writing documentation with read the docs, right? So you either use Markdown or restructured text. On Fedora, we use ASCII doc, which is meant to be pretty much for technical writing. Is the same process, right? So you see this edit this page link over here. If you click that, you get to the repository on documentation. And it's a similar markup language. It's not the same as Markdown, but it's very similar, right? And then there's a tool like RTD that pulls this from time to time and generates documentation, right? And because it's part of a larger project, there's a whole landing page for different Fedora documentations. And then if you go to engineering teams, for example, you'll find different teams, and we're one of them, right? So again, another contribution opportunity is you don't really have to write documentation, but if you're using stuff and you think the documentation is not up to scratch, open a pull request, and that gets added to the website, right? Let's see. So we even have a whole page on contributing, which everything I'm telling you is listed here, right? All of these contributor rules, right? So we've talked about suggesting software. We've talked about packaging and maintaining. We've talked about BOSI, which is testing. If you're a user, the way you file bugs on GitHub, if you don't, you should. You can file bugs for us, right? So instead of you talking directly to developers, you can speak to us and we can help you debug the issue better and then give a well-crafted bug report that will help the developer fix it easily, right? Sometimes, again, if the maintainer knows the tool well enough, we might even be able to figure out what the issue is and submit a patch upstream, right? And yeah, the final contribution opportunities are the least technical. So helping other users, hang out in the channels. If somebody has a question, you know the answer the question, right? Now, in this way, a FOSS community is slightly different from, let's say, a corporate organization that provides software and as a service, because different people in a FOSS community will take on different roles, right? There's no contributor, there's no user. Most contributors are users, and most users can be contributors at different times, right? So this is why we try and avoid the whole contributor user terminology. We're all community members, we do things together. Different people do different things, but everybody is part of the community and you just work on whatever you find interesting, right? Yeah, and the last thing is, well, help us spread the word, really help spread the word out from NeuroFedora to different people. I'm quite happy to take requests for inclusion of software, but ideally we'd want people that use the software to help us maintain them, right? Because if I do package software but I don't use it regularly, it's likely that bugs and issues with the software will slip through, right? Whereas if you maintain software and use it daily, then you're in a much better position to catch any of these regressions, right? It also gives you an incentive, right? For example, I use simulation tools. So I have the incentive to make sure they're up to date, that the bugs are fixed. Whereas if it's an imaging tool that I maintain and I don't really use it on a daily basis, there might be a bug, but it doesn't affect me personally. So it might be somewhere lower on my task list. Right. Aniket, is there anything I've missed, do you think? Morgan?
No, that's great.
Yeah. Does it sound like a whirlwind tour of what we do? Yeah, okay, I'll stop sharing. Any questions? Does anybody want any links while I still have my screen shared? I can share all of these. Okay, I'll stop sharing my screen then. And right on time, that's always great. Okay. So any feedback, any ideas? Yeah, Joe, you really don't have an excuse. If you're not using an open source distribution, open source tools, you should. That's all I can say. Just for all the developers, we've already started testing out Python 3.10. So we might already start filing issues if your package is in Fedora, because quite a few packages seem to have minor issues with Python 3.10 where a few things have changed. So yeah, so the way things work is there's a special interest group that takes care of Python called the Python SIG. When a new version of Python enters alpha or beta, they rebuild everything in Fedora with the new version to see how things are, what works, what doesn't work, and the file bugs. And then poor maintainers like Aniket, Morgan, and I have to respond to these bugs and, well, and then, poke poor upstreams to fix their stuff, even when Python 3.10 hasn't just been released. Yeah.
Yeah, just wanted to add, yeah, if you are interested in neuroimaging, please get in touch. There are definitely some packages that got our eye on, and there are some issues. It's unfortunate that FSL and FreeSurfer, which are kind of like the two main tools that I have to use, or I should say that these days I get a lot of I mentioned Singularity. A lot of the Enigma processing, which is big psychiatric, multi-site data processing initiative, uses Singularity. It's basically FSL, FreeSurfer, and Singularity containers these days. But it was nice that it was right out of the box. On Ubuntu, I have to build a Go project. But there's AFNI and ants and like to target the kind of non-Python tools, if possible. The projects that are the kind of the hardest for people to add.
Yeah. I think most people are quite happy to install Python tools with pip in a virtual environment, unless they have a compile component where it might get tricky. But it's really the C, C++, and that kind of software that requires compilers and linkers and flags and all that kind of thing that a lot of people in neuroscience that may not come from a computing background may find hard to build. Yeah.
And we've as part of NerdTechX, we've finally got some good Linux support for a bunch of consumer headsets. So we out of the box, we'll be able to have EEG and at least one FNIRS device. Looking forward to that. We were, Blue Z's getting deprecated, and most of these are Bluetooth related. So we were switching over to library.
Morgan, do you want to share a link to Neurotech in the chat so everybody can?
Well, sure. I mean, let me just point, or certainly.
So if there aren't any comments, are there any tools that, at least for computation neuroscience, that we should be targeting for inclusion in your Fedora? I've managed to get all the main simulators. Thomas, I'm going to write up a documentation page on CUDA and Gen. so that at least it's easy for people to install it. But apart from that, are there any tools that we haven't considered yet? And additionally, is there anything you think we can do better? I mean, I haven't applied for any grants and things because we are working on a community-based thing, but yeah, grants are always helpful. It's just, I wasn't sure if it's worth the effort of writing and applying for a grant when you kind of, yeah.
As you mentioned, the CUDA issue, I mean, it's obviously for us, it's slightly annoying that just because that isn't fully free and open, that that we can't have the software included in anything that is emphasizing that aspect, right?
Yeah.
Yeah, I'm not sure actually how it all works together. Maybe you can say a couple of words about that. I mean, in the principle, of course, you could install the software without CUDA and just run it on the kind of host only, like CPU only kind of mode, even though that's a bit of a waste of energy because the whole selling point of it is to use GPU, right? So I don't. How do you see that? I mean, is that?
Well, if I can share my screen again just for a minute to show you. So where am I? Oh, wrong window. So yeah, so Fedora has a sister repository called RPM Fusion, right? So for example, NVIDIA proprietary drivers also won't go into Fedora, right? We want users to use NoView, but NoView is based on reverse engineering. I mean, the performance is really not as good as the proprietary drivers. So RPM Fusion is another community effort to provide software that is either patent encumbered or is under a non-free software license, right? I'll share this link with you in the chat. Here. So for example, if you want to install NVIDIA, then so I have that bookmarked, right? So it has a whole document, and what they do is they build the binary RPM for you. So at the end, it's another single command that says dnf install blah, 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 and you have NVIDIA set up on your system, right? You don't have to deal with the binary that NVIDIA provides because I don't know if it still does this, but back in the day when I used the binary, it would try to recompile your kernel sometimes for some reason because it wouldn't have the compatible, So what RPM Fusion does is that they build the NVIDIA binary into an RPM and put it in a repository for you so you can do dnf install. I need to double check if CUDA is, I mean, I do see CUDA mentioned here, so it's possible that they already include CUDA. So we may be able to put anything that requires CUDA in RPM Fusion, right? So that is one option.
Right.
So for example, I mean, there we are. It does say that there's a CUDA. You should be able to technically install it. Unfortunately, I don't have any NVIDIA hardware. If I had some NVIDIA hardware, I could test all of this out, but I don't have any anymore.
Yeah, that is a problem too. Yeah, I know of that. I'm in a similar boat actually.
Yeah.
So yeah, I'm running. I've got a NVIDIA card, so this is what I use, and the Red Hat has also wheels for PyTorch and TensorFlow to use these CUDA installations, so that without exactly being it helps with the installs and getting up and running with what is generally what people are using, CUDA for, at least in the machine learning data science world. For me, it's usually, a lot of the neuroimaging tools, it's like I have to install old versions of CUDA. So, the dependencies are on like, CUDA 8 or something like that.
Yeah. Well, I mean, Gen is literally now to a point where just depending whether you have a CUDA path set or not, it will install one way or the other. So at the point when you get to Gen, it doesn't really care. But of course, there's no point really in doing it if you don't have CUDA, unless you want to just develop your programs and then run them somewhere else eventually.
Yeah.
But I'm just saying, so the dependence is pretty lightweight. Yeah, in principle, one could provide it.
So it's not it's not a build time dependency then. Is it only a runtime dependency?
Well,
or do you need CUDA to build Gen then?
No, it will build one way or the other, whether CUDA is there or not. Yeah.
Okay.
The same source.
But if I build it without CUDA, will that build, if I install CUDA later, will that build work with CUDA, or will I have to recompile it with? Because if it's a runtime dependency, then I can only include it in Fedora and have a requirement on CUDA. So if somebody has RPA Fusion enabled, then Gen will pull in CUDA. If it's a build time dependency, then I need to build it with RPM Fusion because I need CUDA.
Yeah. Well, the answer is actually it's not super trivial. So if you're using Gen as a C++ package, then there is no actual build happening when you install it, and so it's all runtime dependency, so to speak.
Okay.
But if you want to use it from Python, then we do build a library up front, and that would then I guess would become a build time dependency, I suppose.
Mm-hmm.
Even though there is some recompilation going on while you're using it from Python, but that's only your code. So there is a library in the background that is compiled once, but that's only when you're using it from Python. When you're using it from C++, it works pretty much like a source library.
Okay.
So it's a partial answer. So it's in its entirety that becomes very muddled then, right? So
yeah.
But we could talk about it offline. I mean,
yeah, because a few people have talked to us about NVIDIA support and CUDA support, because I mean it's quite common now for a lot of data analysis tools, as Morgan said. And our answer always has been, well, we can try RPM Fusion and see how that goes. I mean, the other thing always is, I mean, I can help you build the RPMs and everything, and you can host the packages yourself in the repository. That is also doable, right? It may not be there, but we'll add a page on our documentation that says this hosts its own repository there where it's built with CUDA, and there'll be 2 commands to enable the repository and install the package. So that can also be done. So I can certainly do the main work of building the RPM. The question of where it then gets published,
would be different. Yeah. I would be interested in trying it out if you are interested. I mean, obviously it's your choice, but
I mean, I'm happy to say that I think I've done most of the comp neuro tools that are commonly used. There are 1 or 2 things still remaining, but they are long term because I have to work with upstreams to fix a lot of bits. So I think I can probably put Gen up as my next task and work on that and see how that goes. Yeah.
And we definitely would be interested to see how it goes.
Yeah, that sounds good.
Cool.
Yeah. Any other feedback? I think you may have noticed that I'm trying to model the software working group a little more on a FOSS community rather than a standard academic special interest group. And it's an experiment, and we'll see how that goes. Yeah. Okay. I think I'll drop one last link. If you have any questions, you can always come to us on all our channels. There's also a Fedora discourse instance over here, right? Literally ask@fedoraproject.org. Yeah, if there's anything neuroscience tagged, I get a notification. So if you ask a question there, I'll answer. Yeah, Morgan, I've run into some people that have asked me not to suggest if not true, then false, that website. I'm just pointing it out. It may work. I don't have NVIDIA, so I don't know. But some people have pointed out that you shouldn't use it.
No, we can't hear you.
Can't hear you, Morgan. Morgan, we can't hear you.
Sorry. Like you said, NeuroFedora is really trying to be a real open source community, and you know, so yeah, these are asides for academics who have particular dependencies that they can't, they are obliged to use, and are really, you know, a separate problem. Anyway, but yeah,
Okay, that's good. Yeah, we're 10 minutes over. So if there's nothing else, we can, well, one of the hosts can please close the session because I can't do it now. Thanks for coming, everybody. Thanks very much. Yeah, if you have any feedback at all, please do drop me a message anywhere, Twitter or GitHub or whatever.
Thanks a lot, Anko.
Thank you for coming.
Okay.
Thank you. That's very nice.
Thanks.
Bye.
Bye, everyone.